Now let's compute the cross product. Let's see how we can compute a cross product. And it says that we have to compute the cross product of A and B. So A cross B and B cross A. Now remember, in dot products, A dot B, is equal to B dot A. But so that's not the case for cross products. A cross B is not equal to B cross A because the direction of the resultant vector is different. So it says now we have to check the answer by showing that each A and B is perpendicular to A cross B and B cross A. As you know, the resultant vector of a cross product is perpendicular to the plane of the vectors that the cross product is being taken of. So the resultant vector of A cross B will basically be perpendicular to the plane AB. And so like if this is vector A and this is vector B, that means that the cross product of these two vectors will either be outside of this page or into the page, because only those two options are perpendicular to A and B, right? So now we have A as 2i plus j minus k and B as I minus j plus k. Two vectors given to us. Now we know that if A is equal to this and B is equal to this, then A cross B is basically found by using this method. Now what is this really? Well, this is a very simple way of calculating the cross product, right? Now here's the thing. Basically, in the first row you write down I, j and k, okay, because those are the two common things in both of the vectors. Now in the second row you write down the coefficients of A, so, and under the correct column. So in the case of A, A1 is the coefficient of I, so it comes under the I column, right? A2 is the coefficient of J, so it comes under the J column. A3 is the coefficient of K, so it comes under the K column. And in the third row you write down the same way for the coefficients of B. So B1 comes under the I column because it's the coefficient of I in B, and same for B2 and B3. Now what do you do once you make this? Well, you write down the actual coefficients, obviously, as they are given in the question, and then you expand. And how do you do that? Well, first off, you basically, like, if you first take the first column, right? So you cancel out, you take this I, and you basically cancel out its column, and you cancel out its row, right? And then you write down I, and then you multiply it with the product of these two and these two, the basically the diagonals that are remaining. So 1 into 1 is 1, and from that you basically subtract the product of the other diagonal, and minus 1 into 1 is, and minus 1 into minus 1 is 1. So basically that gives you 1 minus 1, right? And then basically for the second, in the case of J, now let's see what you do in the case of J, right? Let's just erase this. Okay, now the second step is to cut out the J column. So basically the row of J is the first row and the column of J is the second column. Now what remains are this term, this term, this term, and this term. Now the J term will have a negative sign because that's just convention, and basically it will now be multiplied with the same rule, right? So 2 into 1 minus negative 1 into 1. So 2 into 1 minus negative 1 into 1, which basically gives you 2 plus 3, right? Sorry, 2 plus 1. And that's exactly what you've done here. Now for k, here's what you do. Again, you cancel out its column and you cancel out its row. And these are the 4 terms remaining, right? And j was negative, so k will be positive. So basically now, again, in the brackets, 2 into negative 1 minus 1 into 1. So 2 into negative 1 minus 1 into 1, which basically gives you minus 2 minus 1. And that's what you have here. So this is just a very quick way of basically, so the only thing that you have to remember here is that I is positive, j is negative, and k is positive. This is just the convention that we follow, right? And the only case where j would become positive is if the the term that it's being multiplied with is also negative, right? That's just simple maths. So now a cross b basically gives you minus 3j minus 3k once you calculate this entire thing, right? And b cross a, as you know, is in the opposite direction of a cross b, because obviously again, if you have this in the plane, and let's say this is a and this is b, and if you do a cross b, that would mean that the resultant vector is either into the page or outside of the page, right? So whatever result you get, the vector of b cross a will be in the exact opposite direction, which is why if you just basically negative a cross b is equal to b cross a. So that's why you get my 3j plus 3k instead of negative 3j into minus 3j minus 3k. And yeah, that's again the same rule, right? So now we need the verification. You see, if the vector a and the vector b are actually perpendicular to a cross b and b cross a. So let's just first take a in relation to a cross b. So what do? You take the dot product of a with a cross b, right? Because dot product is basically what the result of this is basically the magnitude of a cross b into cos of the angle between them, right? So the only way that this term becomes 0 is if this term is 0, which in this case it isn't, if this term is 0, which in this case again it isn't, and you're only left with this must be 0. And how is it 0? If theta is equal to 90 or it is perpendicular, in other words. So if this turns out to be 0, that means that a is indeed perpendicular to a cross b. And what do you know? It is indeed equal to 0. Now let's take b in relation to a cross b in the same way. Well, it turns out to be 0 as well. Now let's take a in relation to b cross a instead of a cross b. It gives you 0 again. And lastly, b in relation to b cross a, it gives you again 0. So that's how you prove that the original vectors are perpendicular to their cross product.